Hello and welcome to all the attendees to today's session, How to Design Secure Application in the Cloud by the speaker Adora Nudu, software engineer at Microsoft Mixed Reality, creator at Adora Hacks, and a public speaker. I am Ritika Chakraborty and I will be your host for the day. Do let me know if you can hear me well. Please note the session will be in listen-only mode and will last for 40 minutes, out of which last 10 minutes will be dedicated to Q&A, requesting all the participants to post your questions in the Q&A window. Should you need any assistance during the session, please use the chat box. Also, if you face any audio video challenges, please check your internet connections or you may log out and log in again. An important announcement for the certificate for attendance. Participants need to attend the complete webinar to qualify for the certificate of attendance. Participant should fill in the survey form in the attendees thank you email and answer the 3 questions based on the webinar provided by the speaker with the right answers within the same day. If these two criteria are met, then only the participant will receive the certificate of attendance within 5 to 7 working days after the webinar. Now about our speaker. Adora is a software engineer based in Lagos, Nigeria. She currently works at Microsoft with where she builds cloud services and high-value experiences related to artificial intelligence and mixed reality. Adora is a nominee for the Young CISO Awards 2020, an award for young professionals in cybersecurity who go beyond the call of duty to make an impact in their workplace and industry. She is extremely passionate about the developer community and is trying to drive inclusion for women in technology. Adora also co-organizes community events, contributes to open source platforms, mentors developers through the Microsoft LEAP program, and speaks at technology conferences, meetups worldwide. She publishes articles on software engineering, productivity, and career growth through her blog, Adora Hack, and posts tech content for software developers through her YouTube channel of the same name, Adora Hack. So without any further delay, I would now hand over the session to you, Adora.
Thank you so much for that introduction. It was a lot and I really appreciate it. Thank you so much. Hello everyone. So like she said, today I am going to be talking about designing secure cloud applications. When we think about the cloud, when we think about how computing has evolved, from the beginning, from like mainframes to desktop computers to laptops to our phones to iPads, and now we even have AR, VR headsets. Computing has evolved. At some point in the evolution of computing, the internet also came in. And as we can see, the internet has also been evolving over time. And one of the things that hasn't changed since this evolution started is innovation. People are always innovating, people are always coming up with better ways to do things and all of that. And part of this innovation was what brought about the cloud. And there are a few benefits when you think about the cloud in general. Being able to use applications over the internet without having to install. It's cost effective. You have on-demand self-service. You have the same experience across multiple devices. High efficiency, reliability, flexibility. In some cases as well, if you configure correctly, better security. You have resources available over a network if you're in a company and you need to share things. If you're an engineer, on the cloud, it helps with like, DevOps, online development and online deployment tools. But the truth is, with all these nice things on cloud comes some level of responsibility. And I'm going to play a video for you that illustrates this perfectly. Hey there, I'm going to tell you a story about what happens when you do not protect public resources. This house has water supply in form of a bucket at the compound. This is a housemate who actually needs water. He gets some into his bowl and goes back inside. This second person, who happens not to be a housemate, comes to the public area where the water is and makes it unfit for everyone to use by washing her hands inside. This housemate happened to be walking in the direction of the water and accidentally kicked it. Now all the water is gone. Why did this happen? Because access to the water wasn't properly regulated. How do we fix this? Take the bucket away and keep it in a safe place. Secure the house to prevent outsiders walking by from tampering with resources only meant for housemates. Connect a tap so that housemates get water in a structured way. The end. Hey there. As we could see, let's imagine the water is a resource over the internet. It was just there, open for anyone to use. And as a result of that, anyone could get access to the water, do anything they wanted to do with it. Somebody even accidentally kicked the bucket away and all the water vanished. And these are security risks that could exist in cloud applications, human errors, which is accidentally kicking the water, malicious attacks, somebody knowing that what they're doing is bad and still doing it because they have access to your resource, which is me with my dirty hand going into the water to wash my hand because I can and nothing would happen. And when you have all these problems in your application, it could lead to legal issues, it could lead to compliance issues. You could get some kind of lawsuits because your customers and people will be like, I don't feel safe with my data being used the way my data is being used in your application. And for that, you did not give me a heads up on how you're going to use this data and you've used it the wrong way. I'm going to sue you. But you might not have used it the wrong way. It might have just been a case of attackers stealing the data and using it their own way. But because you didn't foolproof that system, you were the reason why the attackers could get to the data in the first place, and now you have to pay for it. So in this talk, I will be sharing architectural patterns that you should think about when you are trying to think about security architectural patterns. I'm also going to be sharing other things that you should do as somebody writing code when trying to build cloud applications. But before I get right into doing that, I will briefly want to introduce myself. I can't top that introduction, but I'll try my best. My name is Adora, and I am a software engineer at Microsoft Mixed Reality. I'm a tech content creator at Adora Hack, which is a platform that I have created where I share tech things as I learn them, and I also share things that I know and things about my life as a software engineer. I have a blog and I have a YouTube channel. It's the same name. I'm also the co-founder at Unstack, which is an open source meetup, an open source community where most of the talks that we do are hands-on workshops as opposed to regular talks because we believe that people learn by doing. And since I work at Mixed Reality, I'm also on the advisory board for VRARA Nigeria, which is the Nigerian chapter of the VRAR Association. And you can find me on Twitter at Adora Wodo in case you want to ask any questions or just get to know me. I tweet about tech or anything else I find interesting. So when you're thinking about your application, when you start thinking about the fact that, oh, I want to build an app today and that app is going to be on the cloud, you need to analyze and understand what your application needs. So you need to draw some kind of security checklist. And some of the few questions you can ask yourself and ask your customer, ask your PM, ask whoever is worth asking are things like, will my application contain sensitive customer data? And if that's the case, then you might be thinking about data encryption methods that help prevent that sensitive data from being exposed. Okay, where and how will my application's data be stored? Then you're thinking about, okay, am I doing a database? Am I storing? What kind of data is it in the first place? Is it like data that I will do a database, or is it data that I need to have some kind of storage? or is it secrets that I'm supposed to put in some kind of secrets manager? How do I manage that? So you need to think about these things. Will this app be over? Will this app be available over the internet or just internally? Thinking about that as well, because if it's available publicly, then it's a bigger security risk as opposed to it just being internal within maybe a school or a company or something. I mean, it's still a security. There's still possible security risks at that time if you don't configure security properly. But when it's available over the internet, the risk is larger, and you have to think of ways to mitigate that. How do I plan to verify my user's identity? You might think of, okay, what are the right authentication or right authorization platforms that I should use if the app requires that I verify user's identity? Are there any sensitive tasks performed? And does my app perform any risky software activities? Like, for example, am I going to be uploading data onto my app? Am I going to tell people to upload pictures? How do I make sure that those pictures uploaded are actual pictures and it's not just a malware that the extension was changed, and once it gets into my application, then I don't know what's going to happen? You need to ask yourself these questions and answer them. Answering those questions are like self-mitigating possible risks before they even happen. And based on this question, I have there there are multiple patterns that we have, and I have divided those patterns into two buckets. There's data protection bucket and there's the identity management bucket. In the data protection bucket, we have the gatekeeper pattern. And under identity management, we have the federated identity and the valet key patterns. So now the gatekeeper pattern is, like I said, in the data protection bucket, is the data protection scenario. And basically, application functionalities would normally be exposed when they accept and process a client's request. And if the system is compromised and a malicious user gains access, then all the sensitive data will be exposed. This is why the gatekeeper is important, because the gatekeeper helps with request validation. It's limited risk, and we're talking about security right now, and I mean, it helps with security. And this is how the gatekeeper works. So there will be a gatekeeper right before the service, right before the host. So the clients are not able to talk to the host directly, but the gatekeeper endpoint is what is usually exposed to the client. And once the gatekeeper gets that request, the gatekeeper validates the request and sanitizes the request, sends all valid requests to the service, and either sends an error message back for invalid requests or does nothing on invalid requests. And a real life scenario for gatekeepers would be having two endpoints. So I have a public endpoint, which is the endpoint that I expose to my clients, and I have an internal endpoint. And the public endpoint, someone calling that public endpoint puts them in some kind of limited privileged mode. So when the gatekeeper now validates and is able to sanitize that request, and I call that internal endpoint, then I am in full privileged mode. And when I'm in full privileged mode, I can do everything in that application. But for me to get to that full privilege mode, I need to be very secure. I need to be validated as a request that will not cause harm to the service that I am going to. And the next pattern I want to talk about is the valet key pattern, which is under the identity management scenario. So this pattern helps you securely control access to data by using a token that expires after a period of time. And you can use this token for authentication or authorization, or both, if we're being very honest. And let me explain how this works, how this scenario works. So let's say I am somebody that wants to gain access to some kind of cloud resource, but I just shouldn't gain access to that resource anyhow. So I need to go through some steps. So let's say I request the resource first, and then the application validates my request and generates a token for me and returns it back to me, and I'm able to access that resource using that token. Meaning that without that token, I can't access that resource. And even in that token, the token will specify the access that I have, the privileges that I have. Do I have read access? Do I have write access? Do I have both? How long am I supposed to access this token for? From the time this token was issued to me, when does this token expire? So if this token is presented to me at what point does the token expire, and if I still need access to the service, I need to, you know, request for another token. This is something that this value key pattern does. And I got this code snippet from the Microsoft documentation, and this explains it pretty well. So what's happening here is that this method gets shared access reference for upload, is returning a token or a limited access key that allows me, the caller, to upload a file to a specified destination for 10 minutes. So after 10 minutes, this token I have expired. And what happens is it's creating the client, it's setting all the credentials, and it's building the blobsters. Then it's setting my permissions for me, and it's giving me only write permissions. So I have only write permissions here, and I have only 10 minutes. So after 10 minutes, if I present this token back to the application, it will tell me that the token has expired. So I have to request another token. And this helps me with limited access so that I don't always have access to a particular resource. I don't always have access to a particular thing. Because once you give users endless access, that could be a long-term problem in the context of security. The next thing I want to talk about is the federated identity pattern, which is also under the identity management scenario. So it helps us separate user authentication from our application source code, from our business logic, and we can delegate authentication to an external provider so that we can focus on what's actually important as businesses. Most of all these authentication, when it comes to security, when it comes to authentication, using identity providers or STS that have existed for a long time saves us a lot of stress, because these people have been attacked before. If you try to use AAD authentication, if you try to use Google's authentication, if you try to use Auth0, if you try to use these different platforms, IBM's, these people have been attacked multiple times. They've learned from their mistakes and they've mitigated these issues and they've become stronger. So as a business, you would want to delegate that part of your system to somebody else and just know that you have that covered. And then think about your actual business logic. Think about actual implementations for your application, as opposed to doing username and password and you get hacked and you foolproof the username and password, you add two-factor authentication, and then something else happens and you keep trying to mitigate along the way. That can be stressful. And federated identity works with some kind of claims-based access control thing. So where, as a service, I am using some kind of identity provider, I'm using some kind of STS, and that is it. So when a user authenticates to my service, they request a token and I give them back that token. And then me, now as a user, I present that token to the service, and that token has claims. That token has some claims, some levels of access that I have. So, like I said, it's something that you can use this for some kind of authorization and authentication where, okay, this token has this particular claim for this particular tenant. So anybody that is not in this particular tenant trying to use this part of the application, I can kick them out because they don't belong here and they shouldn't have access to this. So this helps you manage that, and then you focus on only what's important. I have talked about, and the federated identity pattern is used in like single enterprise sign-on, for businesses. When you have multiple partners, I talked about different tenants and being able to control which tenant has access to which resource, and in different SaaS applications as well, different SaaS applications that you use, your Google Docs, your Microsoft 365, all these different cloud applications that you use as well. Authentication to these platforms are usually federated identity patterned. And now let's talk about other ways to enforce security using multi-factor authentication. There are multiple factors, right? It's not just only 2FA, there are multiple factors. So you having a password is the remembrance factor. It's like, oh, okay, I can remember the password that I gave. Then there's also the possession factor, which is, okay, you remember the password, great, but you could have asked the owner for the password and they could have given you by mistake. Are you in possession of the owner's phone? Are you in possession of the owner's email address? So if I send a code to that owner, do you have access to that code to type in? If you do, then maybe you are the owner, right? There's also another factor, which is like your biometrics. I'm scanning your eyes, I'm using your thumbprints, and for me to be able to do these things to authenticate you, then it's probably you using this application or using this service or using this device. So I will now know that, okay, I have validated your identity and that is what it is. There's also JIS access, just in time access for resources. So, like I said initially, let's remember the video when I was talking about the video that we watched at the beginning, where we talked about, okay, somebody washing their hand inside the water, somebody coming to dip their cup inside the water, somebody accidentally coming to kick the bucket of water away. People had access to the water throughout. It's not controlled, it's not regulated, and that's why that could happen. With JIT access, you have some level of control. So when you request this access, you have this access, let's say for like 2 hours, and in that time, the kind of access you are requesting for is the level of access that is given to you. So you are giving either contributor access, or you're giving admin access, or you're giving whatever any kind of access. And in that time, that's when you have access to the resources. And after the 2 hours specified, if that's what is specified in your configuration in during the JIT process, after the 2 hours specified expires, you have to request JIT again. What this means is that it's not going to be easy for people to just gain access to resources and do weird things. So if someone is even about to delete a resource by accident, they can't because they'll need JIT access. And once they get JIT access and you're like, okay, why are you about to delete this resource? Because sometimes it could be a mistake. And then they realize and then, they're able to stop themselves from doing that. Also, using stable authentication and authorization platforms also help with identity. I've talked about the federated identity pattern. So stable auth platforms, these platforms that have had these issues and have mitigated them before, you are better off with these platforms than with any other platform. With requiring re-authentication for some kind of action. So let's say you're doing financial actions. So let's say you want to transfer money. You're already logged in into the app, but you finally want to transfer money. Most times in these banking apps, they would ask you to either add your password again, or they'll ask you to put in some kind of PIN or something, just so that they can re-authenticate that, okay, the person about to perform this action is the valid identity. Because somebody can log into an app and go away, and in that time I could get access to somebody else's phone, and if and I could send how much to myself and that could be a problem. So if not regulated properly, could also be a very big risk, if you ask me. Reduce your attack surface. So if you're building an application and there's no need to have maybe some kind of VM, remove that virtual machine. If there's no need to have this serverless thing that you're not using, remove it, because when your attack surface is wide enough, which is when you have multiple resources available, the ones you are using, the ones you're not using, when your infrastructure is a lot, what happens is you are giving attackers multiple ways to try and get into your service. You're giving attackers multiple ways to get access to your application, to penetrate through your application. And the larger your attack surface is, if they try one point and it doesn't work, they'll try somewhere else. If that place doesn't work, they'll try the next place. And that's what happens. But if you had a small attack surface, it will get exhausted real quickly, because when they try multiple places and they can't get access to it, then that will just be the end. Properly handle errors and exceptions. This doesn't help with security, but it helps with cases where your application just fails anyhow. You want to gracefully handle errors. You want to make sure that your application handles errors properly and it doesn't really affect a user's experience. Monitoring your service and triggering alerts are very good, because you can see what's going on in your service. If there is a security threat, you can quickly address it. If there is a bug, you can quickly fix it. Any issue at all, being able to properly instrument your service helps you mitigate issues immediately they come, or even sometimes before they come. Encrypting sensitive data, you don't want confidential information to just be out in the open for anyone to read. You want to, when you're writing code, you want to think about encryption algorithms. You want to think about ways to encrypt this data. Okay, am I encrypting this data in in with some kind of algorithm and saving it somewhere, or am I going to store this data in a secrets manager and just delegate that encryption process to them to manage for me? How do I do that? So that's one thing that you think about as well. And something else is considering threat modeling. So threat modeling is like thinking about the possible threats that your application could have and thinking about ways to mitigate these threats before they come. And there's this popular thing called stride. So if you have spoofing attacks, if spoofing attacks is your threat, then the security property is authentication. And you might want to enforce HTTPS connections to prevent this from happening. If the threat is that people can tamper with stuff, then integrity is the security property. And you want to use valid certificates, valid SSL, valid TLS certificates, so that there's no security risk. If repudiation is the threat, then non-repudiation is the security property. And then you want to enable proper monitoring and instrumentation in your applications. If information disclosure is the threat, then confidentiality is the security property. And you want to encrypt sensitive data when that happens. You don't want sensitive data to just be in some kind of plain text, because when people get access to that sensitive data that's supposed to be confidential, you don't want to know what's going to happen next. If denial of service is the threat, then availability is the security property. And for that, you need to make sure that you have probably multiple instances of your application, so that when one is down, somebody else can call another endpoint. And also properly monitor and instrument your applications. Proper monitoring is good, so that when your service is down, if you have maybe one instance, you're able to know early and you're able to do things that can get your service back up in record time. If elevation of privilege is the threat, one thing that is the security property is authorization. And the way to get around that is by using secure identity management. So if authorization is the problem, you want to make sure that whatever identity management you're using, whatever auth you're using, is something that is secure and can't be bypassed anyhow by attackers. And there are other things, using secure libraries rather in your applications, not using any random open source library that you see on the internet that you're not sure is properly vetted, updating your dependencies each time they have updates that help prevent vulnerabilities, and referencing secrets from a secret manager, not hard coding important secrets in your app settings or your environment variables, because that could be very disastrous. If you want to learn more about security, I would really advise you to check out these links on the Microsoft documentation, Tech Beacon, and IBM. I think that these are really helpful resources that can get you one step closer to your security journey. Thank you very much. And now, if there are any questions, I can take them.
Thank you so much, Adora. It was a very informative session. Uh, Actually, the session was very interesting. The webinar was very interesting. I hope you all enjoyed this amazing presentation, and we hope it was worth your time. So if you are interested to learn more about our programs, kindly take part in the poll that's going to be conducted now. So now we are going to take our first question. What security aspects do you receive along with cloud? Adora?
I don't really understand the question. Sorry.
Okay, the question is, what security aspects do you receive along with cloud?
What security aspects do I receive? A lot.
Um, should I go to the second question then?
Yes, please. I don't know if it's that I can't hear the question well or I don't understand it, but I don't
Yeah,
I'm
not an issue. Not an issue. I am going to the second question. What is the security solution for elevation of privilege?
So I talked about elevation of privilege already, and it's using secure identity management. So when you're thinking about elevation of privilege is more, okay, this person is supposed to have the privilege to do this thing, but somehow somebody has been able to bypass that authorization, and now anybody can do it, or someone that shouldn't be able to do it is doing it. So how you prevent that from happening is by using secure authorization services, using secure identity management. And this goes back to what I talked about the federated identity pattern. This goes back to that because it's like, okay, maybe I'm using AAD, which is like Microsoft's authentication platform, or I'm using Google's authentication, or I'm using Auth0. I'm using these various authentication platforms that have authentication and authorization and have been in the business longer than I have. And so if I'm using their platform, and I follow the documentations right according to how I'm supposed to do things, and I implement all the things I'm supposed to implement, the chances of somebody bypassing my auth is lower, because that wouldn't be that big of a problem anymore. I hope I answered the question correctly. Or I hope I answered it to your understanding.
Yeah, thank you, Adora. The next question is, what are the best application monitoring tools or technologies available within Azure?
The best application monitoring tools available within Azure. I know that I can't directly answer that question, because the only tool that I know is the one that I use, is the one that we use at Microsoft, which is being able to do Geneva monitoring. You can Google Geneva and you would find it. But I don't know if there's any instrumentation or monitoring or any other kind that exists outside the context of Geneva on Azure today.
Okay, so third question we have, any checklist you suggest to secure the applications in cloud?
Um, so yeah, initially I talked about it, right? So the important checklist, things that you can think about, is asking yourself these security questions, knowing the kind of application that you are building. And based on that kind of application, you can now make some certain security decisions. Like if your application has, if your application is supposed to have login, you're supposed to be doing auth in your application, then that's a checklist, right? And then you should think about, okay, how do I do this auth the most secure way possible? If your application requires that people upload things to your app, then you have to think about the fact that you want every upload to be a secure upload, and you want to be able to track insecure uploads and cut them off before they get to points in your service that they can ruin things. If you are going to be persisting data, if you're not building a stateless application, if you're going to be persisting data, how do you want to store this data? If you're going to have confidential information, how do you want to encrypt it? So there's no one size fits all kind of checklist. Depending on the app you're building, you ask yourself various questions that will let you know the security requirements that your application should have.
Okay, so next question is, can we do VAPT for cloud security?
So what does VAPT mean? I don't know what that means. I don't know what that means, so I don't know if I can answer that. Sorry.
Okay, not an issue. So we are taking the next one. Before going for cloud computing platform, what are the essential things to be taken in concern by users?
You need to think about the kind of application you're building, the kind of business, the kind of offering, because even within cloud computing, right, there's so many things. There's the public cloud, there's the private cloud, there's the hybrid cloud. So the kind of business you have, your budget, the kind of service you're rendering would let you know the kind of cloud. Should I go the public cloud route? should I do hybrid cloud, which is a mixture of public and private clouds, or should I do just the private cloud? And even in the context of the public cloud, there's so many, cloud service models that exist. You have software as a service, you have infrastructure as a service, you have platform as a service, and these are different things essentially. So it depends on the model of your business, your budget, and the model of your business and your budget. That basically decides what you go for, what kind of cloud you go for, and what kind of model within that cloud as well.
Okay. The next question is, do we have available security threat model for cloud containers?
I believe so. So I know that if you try to do a quick internet search on Stride today, you'd find multiple things that I believe would help you, and threat modeling in general, just so that you can have an idea. There are multiple things online that I know can be helpful.
Okay. So next question is, how can we make good security application build?
How can you make good security application built? I guess by doing everything that I talked about and more, hopefully. I'm learning about security. And there's one thing, which is the design part of your application. When you are designing, make sure that you are designing your application securely. You're using one of these patterns in places that require them. And when you're writing code, make sure that you are not hard coding, you know, you're not hard coding secrets or confidential strings or anything. And it's just about hard coding them, by the way, but in your pipeline, in your build pipeline, you are not logging any of these things as well, because anybody can get access to that VM, that pipeline, and they can just go and see what your database connection string is, get access to your database, and go and do what they want with it. So having security at the back of your mind in the design process of the architecture process, the design process, when you're writing the code, and even when you are maintaining that code going forward, adding features, taking out features, making the code better, all of that. Having security firsthand at the back of your mind is always something that is very good and something that I would always recommend.
Okay. Uh, the next question is, if my application upload malware file into my storage, does that file have execution right? Meaning, is it possible for the file to execute itself?
It depends on you, and it depends on the malware at the end of the day. And that's why I keep saying have security in mind. The file executing itself might just be the kind of action you perform on the files that are being uploaded. So you might perform an action on that file that will cause that file to, I don't know, self execute, and then that's it. Or I don't think by default anything getting access could like I said, it really depends. It really depends. There's no yes or no direct answer to that question. It really depends on what the aim of the attacker is, and it really also depends on what the structure of the application is, or the structure of your storage is, or both really.
Okay, so one of our previous question, can we do VAPT for cloud security? The actually user has shared the VAPT full form, vulnerability assessment and penetration testing for cloud.
Yes, definitely. You should be able to do um vulnerability assessments for your cloud applications. At the end of the day, it is on the internet. So when I say anything on the cloud is on the internet, if you are going to if you are going to have access to this application over the internet, there's a chance that something could go wrong. And I think this kind of goes back to what I was saying about your security checklist or even threat modeling to begin with. So if you are thinking about possible ways that you can have like issues, then yeah, I think that you can. I think that you can.
Okay, the next question is, how does cloud security compare to on-premises security?
Cloud security is kind of different because, well, on premise, you could have like private cloud, for example, is also needs to be secure. Like I said, in the context of schools or businesses or whatever, they still need you still need security. So regardless of whatever situation you find yourself, you should try to be secure. But when I'm talking about cloud now, in the context of cloud, mostly I'm referring to the public cloud, and that's worse because it's no longer closed. It's not on premise, it's not private, it's open for anyone and everyone. So if you are in a school or you are in an organization, right, at least one person needs to be vulnerable in that organization for something bad, for like attackers to gain access to your thing and then like have access to all your information and stuff like that. And maybe if you give trainings to your employees and all of that, then you can mitigate that from happening. But when you are on the cloud, the direct public cloud that is accessible to everyone on the internet, then it's a different ball game because everybody now has access to everything, and there's no case of, oh, okay, this is the weak link, everybody has the potential to be a weak link. Anything can go wrong on the public cloud because the information is there for everyone to use. The security is also kind of left in some cases to the cloud providers. And if you're not using cloud providers that you believe that you can trust, that could possibly be another problem. So as much as on premise is still cloud, if I'm being very honest with you, when you're thinking about private cloud, I mean you have those scenarios and you still need to think about security in that context. You need to think about security all the time, but the risk is larger on public clouds generally. That's what I believe.
Okay, so this is our last question. How we can secure the web application if the attacker is on same network of the user or using Wireshark finds the token of login and attacker using the token login with the user account.
Um, I that's wild. That's very wild. In that context, I I mean, like I said, if you're even talking about, you still can. And like I said, it's going to be harder for you as an individual or as a small business to do that because it's you. But at the end of the day, what you just mentioned, I'm sure other security platforms have found a way to mitigate. So I think, in all honesty, using the right people, you integrating with the right services would save you a lot sometimes. And just at the end of the day, as much as you try to be the most secure that you can be, there's sometimes that you'd slip up. And if I'm being very honest, when you slip up, you learn and then you try to fix that problem. But I don't think you can always be 100% secure, but at least 99 is great if you ask me. So use services or providers that are more trustworthy. Try to not follow all the rules because it's not an exhaustive list, but try to just always have this at the back of your mind. And if it's harder, I agree that it's harder, but um it is what it is.
Okay. So this was our last question, and thank you once again, Adora, for answering those questions and for the great presentation. It was a pleasure to have you with us, and
Thank
thank you to all the attendees who have actually joined the webinar and took part of in the poll and our uh, and concentrated this presentation.
thank you everyone. Thank you.
Thank you. Now you can end the session and disconnect your line.